Alright, so last video we worked a couple of examples using that formula for area of a circular sector. Now we're going to take a look at one special case when you have sectors and you actually slice something away from them. That's something called a segment of a circle. I'm not going to write out a formal definition, I'll just show you a picture of what that means. So say that you have a circle and you're looking at a sector, and then if you take the points on your circle where the radii meet your circle, if you connect those things, that tiny little sliver, I'll show you here in red, is going to be what we call a segment of a circle. So it's not quite the same, but sort of think of it like if this was a slice of pizza, sort of like the crust of your pizza. It's not exactly the same, but it's kind of the idea. So we want to be able to find the area of that red portion of a segment of a circle. The way we're going to do that is we're just going to take the area of an entire sector, and then we're going to cut off the area of that triangle. And once we cut off the area of that triangle, that's going to give us the area we're looking for. So here's one example right here. I've got this circular sector with a central angle of 120 and a radius of 12. And so I'm going to look at the sector area. It's angle over 360 times pi r squared. Okay, so I'm just going to reduce that as much as I can for now. So 12 over 36 is a third, so 144 pi over 3. And what's that going to go into? I forget off the top of my head. 48. So that'd be 48 pi for the sector. Okay, so now what we need to do is find the area of this triangle and subtract it from 48 pi. Now this triangle right here should be isosceles because those are radii. We need to know the height and the base, and then from there we can do 1/2 base times height. Now if this is a 120-degree angle, that's going to get cut, since this is an isosceles triangle, into 60 and 60. Oh, look at that, another 30, 60, 90 triangle. Your hypotenuse is 12, so that means that the height of this triangle is going to be half of that, and then this little portion right here is short leg times square root of 3, so that'll be 6 square root 3. That's going to tell you that the base is 12 square root 3 because you have another 6 square root of 3 over here. So 1/2 base times height equals half 12 square root 3 times height of 6. And let's see, if we reduce that as much as possible, that's going to be 36 square root of 3. Okay, so that's taking care of our triangle. And so to get the area that we're looking for, I'll go ahead and color that in green here. To get that area, we're going to do 48 pi minus 36 root 3. So the area of that segment when I typed that in, I got about 88.4. And since the units are feet, got to add on feet squared. Alright, so the last one I'm going to show you guys, I kind of skipped over in the last video because I wanted to look at these segments first, because there's an easy way to do that problem and then there's a really hard way. Now you can look at this a couple of different ways. They want to find the area of these shaded parts, or the shaded region. What you could do is you could find the area of one of those segments and then multiply by 4. But that's actually really, really difficult. The easier way to approach this one is to do area of the circle minus the area of the square. And so I'm just going to go ahead and do that real quick. So let's see, that's going to be 81 pi, because the radius is 9 and your formula is pi r squared, minus, oh, okay, well, I don't know the area of this square. Well, what I got to do is keep that going. That's going to be 9. That means I have a square with a diagonal of 18. And every square, when you draw the diagonal, is split into two 45, 45, 90 triangles. You can use Pythagorean theorem if you don't believe me, but it's going to come out to be the same way. So if you call those x, it would be like x squared plus x squared equals 18 squared. Or if you can remember, 18 equals x root 2, and then divide out by square root of 2. And if you do that, that's going to be 9 square root 2. So you divide by 2 and then multiply by root 2 when you rationalize that denominator. And so that's going to tell us if each side is 9 root 2. Well, a square, you're going to do any side times itself. Or 9 root 2 squared. You could rewrite that if you want to as 81 pi minus, let's see, 81 times 2, so 162. Okay, so let's see what we get there. I'm getting about 92.5 when I plug that in, and that's close enough. Make sure we include any units. Well, they didn't give us any, so I'm just going to say units squared, just to indicate that our answer is an area. That should be plenty of information for you all to do the post-lesson check for understanding, all the homework problems, and really get ready for that assessment.